Imagine our world ravaged by hurricane-force winds, with temperatures swinging from scorching heat to freezing cold. Imagine the day lasting just 6 hours on a world where only primitive life forms evolved. This could be our planet if the Earth had no moon. The moon, an 81 million billion ton lump of rock and dust, more than 2,100 miles in diameter, orbiting almost 250,000 miles above our heads. It is the second brightest object in our skies, with temperatures ranging from 250 degrees down to minus 380 degrees and lower. Its gravity is a sixth of that of Earth. Mountains soar to 16,000 feet, and millions of craters litter the dust-dry surface, where no liquid water has ever been found. This is not a hospitable place. And yet, we associate the moon with romance and mystery. The man in the moon enraptures lovers all over the world and feeds our hunger for supernatural myths and legends. We are far from alone in having a moon. There are at least 135 other moons orbiting the planets in our solar system. Saturn has the most with 46, while we have at least 10 mysterious bodies orbiting our planet. 5 are asteroids caught temporarily by the Earth's gravitational field, and 4 are probably remnants of the Apollo 12 rocket. The 10th and largest is our moon. Since long before the birth of humankind, the moon has been the Earth's constant companion. But until relatively recently, we've known little of its true nature, or even how it was created. There are several competing theories. One suggests that the moon is merely an asteroid or planet trapped by the Earth's gravity. Another ascribes the creation to a giant impact on Earth, ejecting masses of material that formed the moon. Clues as to which theory is more likely to be correct came when men first landed on the moon and started unlocking the secrets of creation buried within the lunar rocks.
5, 4, 3, 2, 1. 0. Liftoff. I'm going to step off the limb now. That's one small step for man, one giant leap for mankind.
Between 1969 and 1972, 6 missions blasted off to the moon.
Wow, what a place. What a view, isn't it, John? It's absolutely unreal.
Only 12 humans have ever walked on the moon. But these astronauts did more than just rewrite history. They also returned with samples of lunar rock. These moon rocks are amazingly similar to Earth rocks, but they contain far less iron. This seemingly small difference offers a huge clue as to how the moon was created. It shows that the moon started with a bang. Let's step back 4.5 billion years in Earth's history. The moon does not yet exist. The inner solar system has about twice as many planets as the 4 that exist today. Many of them are on a crash course to destruction. Among them is a planet about half the size of Earth, since named Theia, who in Greek mythology was the goddess mother of the moon. The 2 bodies are on a collision course. Inexorably, Theia rushes closer and closer to Earth. The approaching planet is a terrifying sight. Astrophysicist Jeff Taylor studies the moon's fiery birth. He describes the view from Earth as Theia races toward it.
It might have started looking like a star, or a pretty big star, but then as it got closer and closer, this thing would get bigger and bigger and bigger and bigger and bigger until it just filled the sky moments before the big impact. And then everything would be gone for you as a witness, and there would be a giant flash because everything would be white hot. And if you were standing, or a friend of yours, on the other side of the Earth, they would see the flash in the atmosphere and feel gigantic earthquakes passing through the Earth.
Theia is 4,000 miles in diameter. To put its size in perspective, the meteorite thought to have wiped out the dinosaurs was about 6 miles across. Theia is traveling at 25,000 miles per hour. That's about 20 times faster than a supersonic jet.
This is an object that is the size of Mars, which is about half of the Earth's diameter. So it's a gigantic event of unimaginable power.
As the planets get closer, their immense gravitational fields rip each other's outer layers to pieces. Then, they catastrophically collide. The impact is equivalent to billions of megaton bombs. The impact shears off continent-sized sections of the Earth's crust, blasting surface rocks out into space. These surface rocks contain only a small amount of iron. The atmosphere around the molten planet is filled with rock vapor. Earth's gravity pulls back most of the debris, but some is catapulted into space, although it cannot escape completely. Instead, it is trapped by the Earth's gravity, forming a ring of red-hot dust and rock around the planet. In a process called accretion, the circling dust and rocks collide and fuse with other fragments to create larger blocks.
We can represent this process by olive oil and water. The water here represents the space around the Earth, and the olive oil is the debris thrown around the Earth by this giant impact. And each little droplet that we pour in here represents a given chunk of matter thrown up, blasted off the Earth. We're going to stir this around, indicating the way the debris is being moved around the Earth.
But when Taylor stops stirring, the drops bump into each other and clump together as bigger droplets.
And that process of small things bumping into each other, becoming larger, is called accretion. And that's how the moon formed around the Earth. That's how the Earth formed around the sun.
As the debris clumps together, its combined gravity becomes strong enough to attract even more debris. This chain reaction doesn't stop until the billions of fragments of vaporized rock have gathered into one red-hot ball of matter. In less than 100 years, this cools into a solid lump of rock, 1/50th the volume of Earth. It becomes the moon. When the moon forms, it is just 17,000 miles away, but it doesn't stay as close as that. Its violent birth sets it spinning away from us on a journey that will last for 10 billion years. Absolute proof that the moon is moving away comes in 1969, when astronauts leave an 18-inch reflective plate on the moon's surface. By bouncing lasers off this plate, scientists can pinpoint the moon's distance from Earth to within an inch. Such calculations reveal that the moon is moving away from Earth at a rate of about 1.5 inches per year. So why is the moon on the move? In the 1990s, supercomputers gave scientists a more accurate picture of what happened 4.5 billion years ago. Computer models of the creation impact reveal that the collision of Theia and Earth is a glancing blow. It imparts a rotational force to the Earth. This rotation gives Earth its days and nights. But the huge power of the collision sets the Earth spinning far faster than the Moon, which orbits around it. In these early days, Earth spins once every 6 hours, 4 times faster than today, whereas the Moon takes 20 days to complete one orbit. So the Moon orbits more slowly than the Earth spins. However, the early Moon is 15 times closer than today, which makes the effect of its gravity so strong that, as this graphic demonstrates, it pulls up a bulge on the Earth's surface directly below it. This bulge moves like a tide across the Earth's surface with its own gravity tugging on the Moon. Because the Earth spins faster than its satellite, the bulge is always ahead of the Moon. So it constantly pulls the Moon forward, causing it to accelerate. Any object that travels in a circular motion will move outwards as it accelerates, much like a hammer being thrown in the Olympics. As the Moon accelerates in its orbit, it starts to spiral away from Earth. It's a journey that will continue for billions of years. At the time of its birth, the Moon orbits Earth 15 times more closely than today. But this close proximity puts the Moon in great jeopardy. It faces a bombardment by thousands of asteroids, which will destroy 80% of its surface. It is now 4 billion years ago, a time the scientists call 4 giga-years ago, or GYA. The Moon now orbits 86,000 miles away, still 3 times closer to the Earth than it is today. From our planet, the Moon dwarfs everything in the sky. During this early period of its life, the Moon has its most profound effects on Earth. The massive collision that creates the Moon is so powerful that it knocks the Earth off balance onto an axis of 23.5 degrees. It's this tilt that gives us our spring, summer, fall, and winter. If we spun on a vertical axis, like the planet Mercury, seasons would not exist. Everywhere would receive 12 hours of light and 12 hours of darkness. The poles would be entombed in an eternal freezing twilight, while the equator would bake in endless heat. But the Moon does more than merely produce this tilt. It also maintains it. The strong gravitational pull of our young Moon acts as a global gyroscope, stabilizing the Earth's axis. Astrobiologist Lynn Rothschild explains.
The reason we have this obliquity that holds steady is because the Moon helps to stabilize the obliquity of the Earth. If we had no Moon, we would end up with what the astronomers call a chaotic obliquity. We'd have quite a big shift and fairly low timescales.
Without our global stabilizer, our axis could vary between 0 and 90 degrees. This would alter the distribution of sunlight across the surface of the planet, devastating our finely balanced weather systems. Climate patterns would go berserk. The tropics could find themselves frozen under ice, and Antarctica transformed into a vast desert. But luckily, the Moon saves us from such disasters and allows life to exist.
It turns out that it may have had a really profound influence on how life has originated and evolved on the Earth. In fact, you might almost be able to argue that we wouldn't be here today filming this if the moon weren't up in the sky.
Not all planets in our solar system are so lucky. Mars has 2 moons, but they are too small to stabilize its tilt. As a result, the red planet rolls much more than Earth. Some scientists believe that this is one of the reasons that there is no life there now. When you look at our moon today, the first things you notice are the craters. They tell astrophysicists, such as David Kring, about a distant and violent past.
You can look up from your own backyard and see impact craters on the lunar surface. There are over 300,000 craters, half a mile to over 500 miles in diameter on the lunar surface.
Most of these craters come from meteorites hitting the moon. The largest crater you can see from our planet is the Imbrium Basin. It is 700 miles across. Moon craters come in various sizes, but almost all were created at around the same time. Around 4 billion years ago, a chance alignment of the gas giants Jupiter and Saturn changes the shape of their orbits. This creates a slingshot effect, hurling asteroids toward the inner solar system, straight at Earth and the young moon. For millions of years, asteroids bombard the entire inner solar system.
Some of these impact events would have produced impact craters the size of continents or larger. These type of impact events have the capacity to obliterate any oceans on the surface of the planet and superheat the atmospheres. Life as we know it could not persist on the surface of the Earth.
This period of intense bombardment is called the lunar cataclysm. The Earth's gravity makes it worse, pulling meteorites and asteroids directly toward itself. On its own, the tiny moon might have escaped with less damage, but it's too close to Earth. Asteroids heading for impact with Earth hit the moon instead. The moon becomes the first victim of collateral damage. Most of the craters on the moon formed during the lunar cataclysm. 80% of the lunar surface is destroyed. Molten basalt oozes from fissures and fills impact craters, creating seas of lava. Over millions of years, these will cool, solidify, and turn into maria, or seas, such as the Sea of Tranquility. It is the pattern of dark basalt rock that creates the face of the man in the moon as we know it today. David Kring demonstrates exactly what happens to the surface of the moon when a meteorite strikes. He releases a 5-pound rock from 50 feet above a sand pit. On impact, sand is fired upwards into the air. During the lunar cataclysm, some impacts are so big that material fired upwards never returns to the moon's surface. Instead, it is propelled into space, where it is trapped by the gravity of the Earth, still only 86,000 miles away. Some of these rocks hurtle toward our planet.
You actually would have seen a huge plume of debris rise up off the lunar surface. This cloud, in fact, would have enveloped the entire lunar surface, and out of that cloud there would have been fragments of rock that pelted the Earth. They would have streamed through the atmosphere as intense fireballs to land rocky components on the Earth's surface.
These lunar meteorites are incredibly rare. This is part of one of only 30 lunar meteorites ever found.
So this is a sample that fell in Africa. Analyses of samples like this tell us that there was a cataclysmic spike in the number of impact events that affected the moon 3.9 to 4 billion years ago.
Lunar meteorites contain a record of the geological history of the inner solar system as it was around 4 billion years ago. These rocks are older than the oldest rocks on Earth. The existence of lunar meteorites on Earth started scientists wondering if rocks can be catapulted from the moon to Earth. Could rocks from the Earth also reach the moon? And if such Earth meteorites could be found, might they hold fascinating clues to what was happening on Earth billions of years ago? To blast anything free from Earth's strong gravity requires immense force. Far more power than it takes to launch a lunar meteorite off the surface of the moon. For example, the space shuttle uses 15 million horsepower to escape from Earth's gravity. The lunar module needed just 6,300 horsepower to lift off from the moon. But just how big an impact would it take to blast debris off of the Earth? Award-winning astrophysicist Guillermo Gonzalez from Iowa State University has figured out the answer to that question.
The crater in northern Arizona, Meteor Crater, even that, which is really big when you go right up to it, wasn't large enough to catapult any significant amount of material beyond Earth's atmosphere. But when you're talking about, say, the crater that killed the dinosaurs in Mexico, now that one was probably big enough to start launching some at least small amount of material beyond the Earth and have some of it land on the moon.
Impacts on Earth during the lunar cataclysm are far bigger than the dinosaur extinction event. They impact with such power that they punch holes in the Earth's atmosphere. Rocks and debris thrown skywards escape through these holes. Once in space, some of the debris is vacuumed up by the moon, orbiting just 86,000 miles away.
And it eventually makes its way to the moon, where it lands. And then when it lands on the moon, of course, it could be further broken up into smaller pieces depending on how fast it hits the surface.
Landing on the lunar surface, they remain perfectly preserved in the vacuum of space.
The early Earth, unfortunately, erased its early history, but it left a record of it, at least a partial record of itself, on the moon. And if we can find some fossils or at least remnants of early life in these Earth rocks on the moon, that can help us answer these difficult questions about the origin of life.
Gonzalez believes that more than 1,000 pounds of Earth rock could be spread over every square mile of the moon's surface.
It's the only place in the solar system that we can go to learn about the origin of life, because once the Earth rocks get to the moon, they're preserved there in a pristine form. There's no water cycle on the moon, there's no more active geology, and they get buried relatively quickly from the material from other impacts on the moon. And so they're preserved from the solar wind and other things as well.
So far, no Earth rocks have been found on the moon. Gonzalez will have to wait until the next moon mission, in the hope that these priceless rocks may then be discovered. The first 500 million years of the moon's journey from Earth has been a violent one. Over the next billion years, the moon continues its escape from Earth and out into space. Its passage changes the face of our planet beyond all recognition. The power of its gravity creates tides thousands of feet high, stirring up the oceans of the Earth. This creates the conditions for complex chemical compounds to form. The moon is aiding the creation of life on Earth. 3 billion years ago, the moon is still escaping from the Earth, and it now orbits almost 200,000 miles away. The effect of its gravity is weaker, but it still has the power to radically change our planet. For now, the Earth has water and oceans, and the moon is stirring things up. It's too far away to have a dramatic effect on the rocks of the Earth, but the moon is affecting the oceans. As the moon passes overhead, its gravity creates tides in the water. But these are not like the tides of today. These are thousands of feet high. Astronomer Neil Cummins studies how the early moon affected the tides.
When the moon first formed, the tides were something like 1,000 times higher than they are today. They would have gone inland as a wall of water, 10,000 feet high as a huge mountain. They probably would have covered hundreds of miles. And then they would come back, scouring the land, taking debris from the surface of the Earth into the oceans.
The material sucked into the seas contains minerals and nutrients. The tides created by the moon churn these into the most crucial cocktail in the history of Earth, the primordial soup. Different combinations of minerals are bound together and torn apart. It's in this violent melting pot that the right combination of minerals is forged into life. Cummins believes that the spark of life might never have occurred without the moon's power to churn up the primordial soup.
The moon created those tremendously high tides back when it first formed that allowed the oceans to fill with minerals, that allowed life to evolve, that allowed us to be here.
The tides may have even helped the first DNA to evolve. Some scientists believe that the changes in chemical concentrations when the tides go in and out cause the DNA to split and replicate. The enormous moon-induced tides have a further vital role to play in the history of the Earth. They help the whole atmosphere of the planet to calm down and become a more hospitable place in which more complex life can evolve. In our look back to 3 billion years ago, the Earth is a very different place. The impact that creates the moon sets the Earth spinning faster. It spins so much faster than it does now that a day lasts just 6 hours. This high-speed spin has devastating effects right around the Earth. The rotation of our planet is one of the most influential factors determining global climate. The spin of the planet creates winds and vortices in the atmosphere. The faster the spin, the faster and more violent the winds. Billions of years ago, when our planet rotated 4 times faster, the atmosphere whips over the land.
When a hurricane occurs today, 100-mile-an-hour winds, trees are blown over, houses lose their roofs, tremendous amount of flooding. But in a day or two, it's gone. Things settle back to normal, people get on with their lives. Imagine if we lived on a world in which those kinds of winds were continuous.
This is the climate of our fast-spinning early Earth. A place with constant hurricane-force winds and giant 10,000-foot tides. This is far too hostile a climate for life to evolve into more complex forms. But the devastating tides that the moon is creating begin to pacify the hellish climate. The tides affect the speed of rotation of our planet, eventually lengthening a day from 6 to 24 hours.
I want to show you how the moon has slowed the Earth's rotation from 6 hours to 24 hours. I'm going to do that with this globe here representing the Earth, of course, and this lens representing the moon. Ruth, is going to be the moon. Okay, so here's the Earth going around much faster than the moon orbiting the Earth. Today, of course, the Earth goes around once every 24 hours, and the moon goes around us about once every 28 days or so. Now, the moon creates the tides. The high tide, or one of the high tides, is almost directly underneath the moon. So, for example, there would be a high tide right here, created by the moon.
The moon lags slightly behind these tides because it orbits more slowly than the Earth spins. The moon's gravity pulls back on these tidal bulges, creating drag that slows the spin of the Earth.
And as the water hits the continents and islands and other nasty things in the way, the friction between them slows the Earth down from the 6-hour day to a 24-hour day.
As the Earth's rotation slows, the atmosphere ceases to whip around the globe. Hurricane-strength winds are no longer the norm, and more complex life forms evolve in the relative peace and calm of our planet.
I really think that we owe the moon our existence today. Without it, the world would have evolved differently, and as a result, we would have evolved differently. We would not be the creatures we are.
The power of the nearby moon has dramatically reshaped our planet. Over the next 3 billion years, the moon continues its journey out into space. The moon's influence has waned, but hasn't disappeared. Some scientists believe it causes earthquakes and volcanic eruptions, while many laymen still believe that the full moon affects our human behavior in bizarre and inexplicable ways. Today, the moon orbits Earth 250,000 miles away. It's 15 times further from Earth than when it first formed. It appears as a distant and mystical object in the sky, and its gravitational pull is far weaker than it used to be. The moon's gravity is now so small that it exerts the same upwards pull as a pea held about 20 inches above your head. But some people still believe that even this weak power from the moon affects human behavior. The moon's 29-day orbit around the Earth is called the lunar cycle. During the lunar cycle, the appearance of the moon changes because it is constantly moving relative to the sun and Earth. Volcanologist Steve O'Meara thinks this changing sun-moon alignment is critical.
I'm going to demonstrate to you how the moon goes through its lunar cycle. The volleyball is the moon, I am the Earth. Now the first thing you should know is that the moon goes around the Earth in about a month. Now we're going to start off at this position here, which is where the moon is directly between the Earth and the sun. This is new moon. When I look at the moon, I see it totally in shadow. Now, as the moon moves in its orbit, you can start to see that part of its disk becomes slightly illuminated and it forms a crescent. This is the crescent phase. As the moon moves further, you see it in a half phase. When it's totally opposite the sun in our sky, here we have full moon. All of the moon is visible, fully illuminated. Now, as the moon continues in its orbit, we see the shadow returning and the phase is diminishing. This is the waning moon. Now we have a waning crescent, and finally we return about a month later back to new moon, and the cycle starts all over again.
The full moon has long been associated with mystery, aggression, and horror. Studies show that the behavior of some animals changes during the lunar cycle. Some creatures' whole breeding cycle is dictated by the moon. Scientists have investigated the link between predation and the full moon. Researchers think that the increased moonlight helps some nocturnal hunters track and kill their prey. Although the idea that wolves howl more often on a full moon is nothing more than a myth. Yet, if some mammals do become more active at full moon, might this aggressive lunar trait extend to humans? The streets of San Francisco. Officers Healy and Mahoney of the San Francisco Police Department gear up for another night patrolling the town. They have been policing the tough Tenderloin district for the past 10 years. But this is no ordinary night. It's a full moon. And on a full moon, things definitely feel a bit hotter.
I think some of the clientele we deal with, they think it's a full moon every day, I think, but there's a noticeable difference. You could pretty much ask anybody who works in, service jobs like police, fire, paramedics, hospital workers. They'll all tell you that during the times of the full moon, business just goes up.
But is there any scientific evidence of human behavior being affected by the moon? In 1976, the American Journal of Psychology studied 34,318 crimes and found they occurred more frequently at full moon. A year later, researchers studying 18,495 psychiatric patients found that hospital admissions peaked during a new moon. However, a series of more recent studies reveals no link between human behavior and the lunar cycle. And yet many people still believe in the power of the full moon, possibly because of horror movies and folklore. For generations, we have been led to believe that murder, death, and even mythical creatures such as werewolves are linked to the full moon. It's not surprising that over time, we start to believe the link is true. And the myth of the full moon is kept alive. The effects of the moon on humans may be minimal, but some scientists believe that its gravity still exerts a major influence on the planet itself. It's not only the moon's appearance that alters with the lunar cycle. Its gravitational pull varies as well. At new moon, when the sun and moon are aligned, their combined gravity tugs even more than usual on the Earth. As the moon makes its way around the Earth, it pulls us in different directions. When there is a full moon, the sun and moon pull in opposite directions, in a kind of astronomical tug-of-war. For most of the lunar cycle, there is no danger for Earth. But when the sun and moon are aligned, their combined gravity creates the maximum stress on the Earth's crust. Some scientists suggest that this can trigger devastating natural phenomena. Volcanologists Steve and Donna O'Meara use this cycle to help them predict eruptions. While other scientists check sulfur levels and study seismographic data to predict eruptions, Steve and Donna plot the position of the moon, which they believe has the power to trigger eruptions at certain points in its orbit. The O'Mearas believe that in the complicated cycle of tugs and pulls from the sun and moon, increased stress can distort molten rock under the Earth. At the crust's most unstable points, where volcanoes form, the pressure sometimes becomes too much and triggers an eruption. The O'Meara's eureka moment comes in 1996 on an expedition to an erupting volcano called Arenal in Costa Rica.
Well, the coolest thing is that all volcanoes are different. They're just like people. They have different personalities. I mean, obviously there's different types of scientific volcanoes. This is a shield volcano, which has very fluid eruptions. Stratovolcanoes have huge eruptions. And volcanoes, we've actually gotten to know some, and like Arenal volcano, we call the Brat, because it's just always.
During their 2-week expedition, Arenal lives up to its nickname, erupting 15 times. They realize that the biggest eruptions occur whenever the moon is directly overhead. By tracking the moon's position over Arenal, the O'Mearas predict eruptions with an accuracy of 80%, a pinpoint accuracy unparalleled in the world of volcanology.
In one of them, we in fact woke the villagers and told them that get prepared, there's going to be an eruption at 12:30, and bang, 12:30, the thing erupted right on schedule.
Since 1996, the O'Mearas claim to have used the moon to correctly predict eruptions all around the world.
Either I have to be the luckiest person on Earth, or the moon is affecting volcanic eruptions.
But the moon may trigger natural disasters on an even bigger scale than volcanoes. One scientist now believes the moon may have caused 2 of the worst natural disasters of recent years. The October 2005 earthquake in Pakistan and the 2004 Asian tsunami. Today, the moon is still on its journey edging away from Earth at 1.5 inches per year. Even from 250,000 miles out in space, its gravitational pull can still affect our planet. It is suggested that the moon can trigger volcanoes, but geologist James Birkeland argues that it has a far more destructive role. He believes that the moon triggers earthquakes, quakes that kill many thousands of people. (1994), and Birkeland travels to Peru to witness that rare moment when the sun and moon perfectly line up, creating a solar eclipse.
In Peru, a large earthquake is called a terremoto, and we saw this great eclipse, and the Peruvian guide said, "I am so glad you were able to see our eclipse. We in Peru have a tradition. We watch the eclipse and then we wait for the earthquake."
This ancient Peruvian belief that solar eclipses are involved with triggering terremoto, or earthquakes, supports something Birkeland has been investigating for the past 3 decades.
They have known what I've known for 50 years almost, that the lining up of the sun, moon, and earth often can trigger quakes.
The Earth's crust is made up of 7 tectonic plates that bump and grind against each other, creating a series of fault lines. At these points, the opposing plates scrape against each other, sometimes slipping or pushing upwards. This sudden movement causes earthquakes. Birkeland thinks that the relative position of the moon and sun above these fault lines is critical in the triggering of earthquakes.
When I saw the ocean tides due to the passage of the moon, then it occurred to me that perhaps it might loosen up the fault lines and sort of lubricate the faults and make them easier to slip.
He monitors the location of the sun and the moon during the lunar cycle as they pass over these danger zones. He also factors in how close the moon is to Earth, since the moon's orbit isn't a perfect circle, it's elliptical. The nearest point of the moon's orbit is called perigee, and its furthest is called apogee. At perigee, the moon's pull on the Earth is 20% stronger than at apogee.
Now the Earth is here, and the moon travels around the Earth in a very elliptical orbit It's exaggerated here, but when it's at its near point, we call it perigee, it's only about 221,000 miles away from the Earth. When the moon is close, its effect on our tides is far greater than it is over here at the far point, at apogee, 253,000 miles away, just 2 weeks later.
By combining all this information, Birkeland calculates how much pressure the moon is putting on certain fault lines around the world as it passes overhead. He suggests that a new moon at perigee can actually cause unstable fault lines to slip. His technique has allowed him to predict several earthquakes in the past decade. But his theories are controversial. In 1989, Birkeland was suspended from his job as county geologist for Santa Clara, California, until he promised to stop making predictions that caused mass panic. Other scientists doubt that there is a link between the moon and earthquakes, but Birkeland claims that some of his predictions have proved to be correct. October 1989. Birkeland warns the city of San Francisco that a big quake is about to strike. A few days after his alert, during the World Series, Birkeland's tragic prediction comes true.
When the World Series quake hit, I was on the 7th floor of the county building. When, boom, the P wave hit. And for 2 seconds, I was elated. I got my quake! And then I didn't want any part of it because I was being rocked back and forth. I held onto the counter. It was frightening.
The 6.9 magnitude quake causes $6 billion of damage and claims 63 lives. It's the biggest earthquake to hit San Francisco in 80 years.
Predicting a 6.5 to 7 from the Bay Area when we hadn't had such a quake since 1906 quake is a pretty good call.
Birkeland's ideas are radical, and the exact nature of the moon's influence on earthquakes is not well understood. However, in 2004, Birkeland predicts that a huge earthquake will occur around the time of the full moon, just after Christmas. The earthquake that triggers the Indian Ocean tsunami duly occurs on December 26, 2004, at a full moon. In 2005, Birkeland predicts a 7.0 earthquake, and within weeks of his prediction, a 7.6 magnitude earthquake hits Pakistan, just after a solar eclipse over the country. Could this be a demonstration of the moon influencing our planet, even though that influence is waning? Today, the moon and sun appear exactly the same size in the sky, meaning that the moon covers the sun during a solar eclipse. But let's look into the distant future. 500 million years from now, and the moon is so far from Earth that eclipses are a thing of the past. Less than 2 billion years hence. With the moon no longer holding the Earth on its axis, the planet rocks back and forth. The weather goes wild, and life on Earth is threatened. Billions of years into the future, the moon reaches the end of its journey away from the Earth. Its orbit stabilizes. In 5 billion years, the sun expands as it nears the end of its life. The Earth and moon, so inextricably linked in life, are together in death, engulfed side by side by the awesome heat of our dying sun.